I'm Rubin. I'm the head of the Laboratory for Familial Dysautonomia. My laboratory is located at Fordham University. Our research focus currently is on finding new therapeutic approaches for treating familial dysautonomia. It's basically a disease that affects the autonomic nervous system, which is the system that controls all of the biological functions that we don't think about. Familial dysautonomia has many symptoms associated with it. We have the effects on blood pressure, we have the effects on heart rate, we have the effects on sweating, we have no overflow tears, we have autonomic crises, which are periods in which time the individuals have high blood pressure associated with vomiting. The effects of familial dysautonomia affect really the entire individual. It also affects the entire family. It's very difficult to plan one's day when one doesn't know whether the child is going to go into hypertensive crisis, require hospitalization or other kind of medical care. So the focus kind of becomes on the child and when the next crisis will take place. I was aware of the severity of the disease, and I was approached in 2000 to try to help identify the genetic cause of the disease. Up until this point, they knew it was inherited in a recessive manner from the parents, so that both parents have to be carriers in order for the child to have the disease. And based on the observations we made, there is now currently carrier testing going on for the population. The reality is that anybody of Ashkenazic Jewish descent who is in the childbearing ages needs to be tested for familial dysautonomia. After we discovered the genetic cause, we knew that there weren't going to be very many children born with familial dysautonomia. We also knew as a function of that it wasn't likely that any great research teams were going to get involved in trying to help these children, because the number of children was only going to get smaller as time progressed. We felt we didn't want to abandon these children. We wanted to do something to help the hundreds of children that have this disease, and focused our energy on that. So when we analyzed cells from individuals with familial dysautonomia, we noticed that a particular protein that is required for normal biological function is almost completely absent in these individuals. We asked the question whether we could increase the amount of this functional protein that would be produced by these cells. Time was of the essence. When we made the decision as to what direction to go in, we decided we wanted to look for compounds that were natural compounds and readily available to the population. If we found something that required FDA approval and would require a 6-year lag before it would be available, many children would die during that period of time. So we focused our energy on natural compounds, and this entailed my visiting health food stores, trying to find a variety of different natural compounds that we could test in the system that we had established in the laboratory. The first item with which we had success was a form of vitamin E. That compound is actually called tocotrienol, but it's in the vitamin E family. The second compound we found is a component of green tea. It's called EGCG. It's readily available, and it too increases the amount of the functional product in the cells as well as in individuals with FD that are taking it. The story really isn't us. It's not me. It's not my lab. It's really the children. And the story is told in their lives. Children who have been inhibited by that disease, been controlled by that disease, been unable to participate in life's events as normal children would be able to, are now able to. It's some tocotrienols and some green tea, and their life has been changed. I got a phone call from somebody in Israel who said, "I want to let you know that we went on vacation for 2 weeks." And I said, "That's very nice," but had no idea what it was that they were referring to. He said to me, "Well, you don't understand. We have not had a vacation since our child was born. Now that we have these therapies that you have developed, The stability of our child's life has now enabled us to go on vacation and to do things like other families do, which we were never able to do until that point. And these stories are being echoed all around the country, actually all around the world. There are children in Israel that are doing very well. There are children in England, in Germany, in the US. And the success that we're having with familial dysautonomia is translatable to other genetic diseases as well. For example, there are forms of cystic fibrosis that would likely benefit from a similar kind of approach. Fanconi anemia is another disease that would likely benefit from this kind of approach. And there's actually a form of breast cancer mutation, the BRCA, which is a similar kind of mutation that would also likely respond to this kind of therapeutic approach. What we accomplish in the laboratory is accomplished because I have people who work with me who are very dedicated to this cause. But to keep those people employed, to keep the laboratory stocked with the reagents that we need, is expensive. It's amazing to see the ability of funds that are gathered by people all over the US to be funneled into a lab to have the impact that it has. Everybody who has contributed funds for this research has a part in the success of the operation. So if there's an FD child who is now not missing class or participating in a sport or having a bar, a bat mitzvah, is planning a wedding, their success has been made possible by the contributions that have been made by the individuals who are giving for this cause. It's very hard to gauge, to imagine what it's like to know that there are hundreds of kids benefiting from what we've done, and the families are benefiting from what we've done. And there's so much more to do, but it's just an amazing feeling.